The Earth and the Moon are basically the same distance from the Sun, yet temperatures on the Moon average an unlivable -18 degrees Celsius. And even deadlier, they range from -170 Celsius during lunar night to 100 Celsius at lunar noon, regularly exceeding both the coldest and hottest temperatures ever recorded on Earth. And while the days and nights on the Moon are about 14 times longer than those on Earth, our planet's relatively fast rotation isn't what spares us from those loony temperatures. What protects us is our atmosphere. By day, it serves as a shield, blocking out the most harmful and energetic of the sun's rays and about 1/3 of the less intense but visible light. At the same time, it traps the infrared radiation, aka heat, radiating out from Earth's sun-warmed surface, keeping us from freezing solid at night. In order for our atmosphere to absorb any kind of radiation, it needs to have some electrically charged particles for passing electromagnetic waves to push around. And most of our atmosphere is made up of gas molecules that don't have an electric charge. They all have a balanced number of positive protons and negative electrons. But some molecules hold most of their negatively charged electrons closer to one side, lending them a lopsidedness that can jiggle back and forth to absorb the energy of incoming infrared rays. For example, water, ozone, and nitrous oxide are all electrically lopsided, so they all absorb infrared radiation. Then there are gases like carbon dioxide and methane. On paper, neither molecule looks lopsided, so it doesn't seem like they should be able to absorb any radiating heat. But in reality, gas molecules aren't motionless. They crash into each other billions of times per second, knocking each other in different directions and also into different modes of rotation and vibration. And it turns out that both carbon dioxide and methane spend most of their time shaking it in electrically lopsided ways, allowing them to absorb infrared rays and help insulate the Earth. Even though many different kinds of molecules can absorb infrared radiation, the vast majority of our atmosphere can't, because it's made of nitrogen and oxygen, which don't get lopsided even when they are vibrating. They're too symmetric. Nevertheless, the lopsided 1% are such good infrared absorbers that they manage to intercept about 90% of Earth's outgoing heat. Each captured ray gets pinged around the atmosphere, and most end up returning to the surface at least once before escaping to space. We don't need to visit the Moon during frigid lunar night to know just how important the game of radiation pinball is for Earth. Ice records from our own coldest climate show that small natural variations in atmospheric carbon dioxide produce relatively big changes in temperature. They also show that, compared to the last 800,000 years, the game today is much, much harder. Thanks so much to the great team over at Kurzgesagt for doing the animations in this video. It's been a lot of fun working with them. And if you